Now, when we talk about scalability, it's a good point to talk that a system can be designed ideally in two styles, or there are two ways to design a system: monolithic system and a distributed system. You might have heard or read it during your academics and all. Now, let us try to understand what is monolithic and what is distributed. So, with the name mono, you might know mono means one, right? This clearly indicates this is one system, but ideally a very powerful big system. So mono means one. So ideally monolithic system is a one powerful big system, which is holding a lot of resources. I will tell what is resources, but for now understand that monolithic means one big powerful system, just like shown in this case. On the other hand, distributed means many systems, but ideally smaller systems. And each system ideally or technically is called as a node. For example, this might be node 1, this will be node 2, 3, 4, 5, 6. This is a 6 node cluster. Together it is called as a cluster. So distributed systems is nothing but many smaller systems coming together to solve a purpose. And each system or each small system is called as a node. And together it is called as a cluster. So in this case, what you see on the screen is a 6 node cluster. Right? So you understood what is monolithic. Monolithic means one big powerful system holding a lot of power. Distributed means many smaller systems coming together to solve a purpose. Together it is called as a cluster. Now, which system is better, monolithic or distributed? We need to think of it. Now, as you know, monolithic means a single powerful server holding a lot of resources. But let's say tomorrow, if you want to scale it or add more resources to it, is it easy? No, not at all. Consider your laptop. If you have a laptop with, let's say, 16 GB RAM, tomorrow you want to upgrade it to 32 GB, might be it's possible. Okay, it will happen once. Again, if you want to upgrade it to 64 GB, okay, it might happen. But after a certain point, you might not even be able to scale that. Or even if you're able to scale, it might not perform accordingly. There are limitations with a single system and when you try to keep on dumping resources. So when I say resources, I mean three things. This is a very important term you need to remember. What do I mean by resources? Because I'll be using this term resources many times in this course. So when I say resources, I would ideally mean three things. Your RAM, for example, let's consider it with your laptop. You might have a 8 GB RAM in your laptop. Hard disk, you might have a 1 TB hard disk. And CPU, you might have a quad core processor, 2.31 gigahertz and all, right? So these are the three resources we talk about: RAM, hard disk and CPU. Now technical words used for it is RAM is called as memory, hard disk is called as storage, and CPU is called as compute. So memory, storage and compute forms the resources for you. Now you can relate it to your laptop so that things are easy to understand, right? For example, if you ask me, my laptop has 16 GB RAM, that means memory is 16 GB, hard disk I have is 500 GB, so storage is 500 GB, and CPU is quad core. Again, compute is quad core. So these are the resources I'll be referring to in the course throughout. Now, the problem with monolithic is that it is not scalable. The reason why I'm saying it is not scalable is a scalable system is something where when you double the resources, the performance should be double, right? Because if I double the resources, that means I'm spending twice on the system. I'm investing double. That means I should get double the performance easily. But with monolithic system, it is seen that after a certain point, if you keep on adding or doubling the resources, the performance is not doubling up. Let's say you might double the resources, the performance might be 1.5 times. That means even though you are adding more and more resources, but the performance is not growing according to that. That means, it is not utilizing your resources in an efficient manner, or it is wasting some of your resources. That is why we say that monolithic cannot scale after a certain point. And this is the reason why you do not see a system with, I mean, few TBs of RAM? At least I have never seen. I have only seen systems with 64 GB RAM, 128 GB RAM at the max. Have you seen a system with 4 TB RAM? No. The reason being, even if you see 4 TB RAM in a laptop or somewhere, it might not justify for the output or performance, right? So monolithic is not scalable. That means when you double the resources, the performance does not double. On the other hand, let's say you have a distributed system with 6 nodes, right? With 6 machines. Now, if someone asks you, can you double the performance? It is very, very easy. You just need to bring 6 more machines so that total number of machine becomes 12, right? Because this is a scalable system. So you can see this. If someone asks to double or the performance, what we need to do is add 6 more nodes to this cluster so that it has 12 nodes, and then the performance will be double or speed will be double. Now, even if let's say you have a 500 node cluster and someone asks you that can you double the performance, you make it 1000 nodes. That means it can scale linearly. There is no dip in performance. And that is why all the big data systems or all the good big data systems are based on a distributed architecture. The reason is scalability, because distributed architecture gives you true scalability. So you can see this monolithic architecture, and when we keep on dumping resources to a single machine, we call it as vertical scaling, because vertically we are trying to add more and more resources. And this is not true scaling, by the way, because after a certain point, there is a dip in performance. However, in case of a distributed architecture, if we add more machines, it is called as horizontal scaling, because we keep on adding more and more machines. We are not adding resources to the existing machines, rather, we keep on adding new machines. And this is called as horizontal scaling, which is true scaling. Even if we have 1000 machines and we want to double, we can easily do this. Now, I hope you are clear with monolithic versus distributed. So basically the point here is that all the good big data systems should be based on a distributed architecture for getting true scalability. Because in IT, the requirement keeps on changing and you cannot get stuck with the old requirements. So throughout this course, we will always talk on this distributed architecture. We will never talk about monolithic architecture. So you can see this. We will never talk about monolithic, always distributed to get scalability. That is why all good big data systems are based on distributed architecture. Now, this has given you a good background that why, or first of all, we covered what is big data as per IBM, the 3 V's and 4 V's. And then we talked about what is the problem statement we are trying to solve. The problem statement we were trying to solve is we want to process huge amount of data. Now, before this comes the challenge that how are we going to store it? So we need to first think of storage, then we need to think of processing, and then we need to think of scalability. And that's what we have talked about. And for scalability, it is said that we should not go with monolithic systems. We should only go with distributed systems because those are scalable, truly scalable. So let's take a pause here and then let's continue with Hadoop. So I hope you have understood that what exactly is a distributed architecture. Now let's talk about what is Hadoop. Can you think of a one-liner definition of what is Hadoop? If you ask me, I will say Hadoop is a framework to solve big data problems. As simple as that. Hadoop is a framework to solve big data problems. Now, why do I say Hadoop is a framework? Because Hadoop is not just one thing that you learn and done. No, it is a bunch of tools and technologies which come together to solve a purpose. That is why I say Hadoop is a framework, not just one thing. There are a bunch of things inside Hadoop which we'll be looking at shortly. You do not have to worry about it right now, right? Now, all the things in this framework are there to solve problems related to big data, nothing more than that. So that is why a single line definition, Hadoop is a framework to solve big data problems, because we are going to deal with big data using this framework related technologies. Now, before talking about Hadoop in a lot more depth, let's see how Hadoop evolved. Now, basically, Google in the early 2000s realized that whatever processing they have to do to make their existing web search work won't scale based on a monolithic architecture, because Google till that time was based on a monolithic architecture, and they felt that with the growing needs, this monolithic architecture won't help, and it won't help them to scale. So they felt the need of distributed computing then. And in the year 2003, Google released a paper, or basically a white paper. White paper is nothing but a theoretical concept given to the outside world, saying this is how we can do the things, but the implementation is not released. So in 2003, Google gave a white paper or a theoretical concept to the outside world, saying if you have huge amount of data, how you can store it in a proper way, right? For example, let's say if you have 10 terabyte of data and you have 1 terabyte of hard disk in a laptop, can you store this 10 terabyte data on one machine? No. So Google gave an idea that how you can divide this 10 terabyte data into multiple small parts and give it to different machines. So this was the idea given by Google, right? So Google gave a paper related to storage, that how to store huge amount of data on a cluster of machines. That means you might have a 10 node cluster. You remember we said that we will be dealing with distributed architecture. That means we will be having more than one node. Let's say there are 10 machines. Now what Google said, that is there a way that we can divide this big file into 10 small parts or more small parts and give each part to a separate machine. So this is what they talk about in this paper. Now consider a very simple example. You have 10 machines with 1 TB hard disk, and consider you have a file with 10 or size of file is 10 terabytes. Now can you store this 10 terabyte file on one machine? No, not at all. That means what Google said, that is there a way that we can divide this 10 terabyte file into 10 parts, each of 1 terabyte, and give it to a separate machine in the cluster. So this is what they talked about in this GFS paper. And this GFS stands for Google File System. So the name of this paper on distributed storage is called as GFS, which stands for Google File System.